Your agent isn't smart, it's a tool user. Most developers try to make their agent smarter by simply upgrading the model, moving from a smaller LLM to a bigger one, or switching providers entirely. But here's the reality, that doesn't actually solve the core problem. What makes an agent powerful is not the model itself, it's the tools the model can use. A model without tools is just a text generator. It can describe things beautifully, but it can't take action, it can't access real data, and it can't complete end-to-end tasks that require structure or logic. When you give an agent APIs, functions, and chained models, you're not just giving it features, you're expanding its capabilities. These aren't add-ons, they completely change what the agent is able to do. In this video, we're going to shift your mindset from prompt engineering to capability engineering. Because once you understand how to design the right toolset, you stop trying to make a smarter model and instead, you start building a smarter system. When you rely on a single LLM alone, you get something that looks intelligent but behaves like autocomplete. A model without tools can't act in the real world. It can't hit APIs, it can't fetch updated information, it can't run calculations with guaranteed correctness. It can't query databases or internal services. So the moment the task requires anything beyond text generation, the agent breaks. It also struggles with multi-step reasoning, not because LLMs can't reason, but because without structured intermediate steps, the model has no scaffolding. It's trying to do everything in one massive prediction. And finally, a single model can't apply external business logic. It can't enforce rules, validate data, or carry forward deterministic operations unless you give it a tool that handles those responsibilities. So the agent doesn't fail because the model is bad. It fails because it's isolated. Tools close that gap. They give the agent structure, action, grounding, and reliability. Capability engineering is the process of defining what your agent should be able to do and then design the toolset that makes those capabilities real. Think about it like building a robotic system. You don't start with intelligence, you start with movement, sensors, and actuators. Only then do you add the control layer. For agents, tools are the sensors and actuators. APIs extend the agent into the world, letting it access live data, services, and knowledge. Functions embed deterministic logic, math, formatting, rule enforcement, and domain-specific operations. Chained models act like specialized modules, doing tasks the primary model isn't optimized for, such as summarization, extraction, planning, or classification. When you wire these tools into the agent brain, the model goes from a generator to a decision maker, and that's the shift we're after, from outputting words to orchestrating systems. This framework is the foundation of everything in modern agent design. Now that we understand why tools matter, let's look at the architecture that makes it work. Everything starts with the user. They provide the initial instruction, the goal, and the context. The agent receives that input and then, this is the key, decides whether a tool is needed. The LLM becomes the executive function, routing the problem to the right component. Next, the tool router determines exactly which tool should be called. This prevents random or incorrect tool usage and forces structure into the workflow. The tool executes whether it's an API call, a function, or a secondary model, and returns structured data. This data then loops back into the LLM, which interprets the result and continues the reasoning process. This feedback loop keeps the agent grounded. Rather than hallucinating results, it uses real outputs from real tools, combined with the model's reasoning. This architecture is what makes agents feel intelligent, not because the model is perfect, but because the system is designed to support it. Let's turn theory into practice and build a tool-enabled agent from scratch. We'll use Python and OpenAI's function calling to assemble a clean, capability-driven agent workflow. Nothing overly complex, but enough to demonstrate real-world patterns. In this workflow, we will have two tools. The first one will be the web search tool, which will enable the agent to pull live information instead of guessing. And then we will pass that data into a fact-checking model tool, which verifies the results and produces a clean, reliable summary. These two tools create a simple but powerful workflow. The agent gathers data, validates it, and returns trustworthy output. This example shows how tools don't just add features, they create capabilities. And when tools complement each other, the agent can perform multi-step reasoning that a single model could never handle on its own. Now it's time to get hands-on. We'll start by creating a new folder and moving into it. Now let's create a Python virtual environment and also let's activate it. When you see the venv prefix appear in your terminal, that confirms the environment is active. That also ensures that all dependencies for this project stay separate from your global Python installation, and it prevents version conflicts and make the project more reproducible. For this project we will need 3 packages: OpenAI to talk to the LLM, Python.env to load environment variables, and requests for making HTTP calls to external APIs like the web search. Let's install them. The next step would be to create a new .env file. In this file, we will paste 2 environment variables: the OpenAI API key, which will be used for communicating with the OpenAI models, and the Serper API key, which will be used to call a web search tool. You can generate a Serper API key from the serper.dev website, and it's completely free for up to 2,500 requests per month. The next step is to create the tools.py file. This is where we will define each tool that the agent will use. In tools.py, we start by importing everything our tools rely on. Those modules will handle HTTP calls, environment variables, and model access. Load.env loads our API keys from the .env file. We also create a single OpenAI client instance that both tools will reuse. The next thing is defining our web search tool. This tool performs a live Google search using the Serper's API. It returns clean, structured JSON, so the agent always has predictable data. In the beginning, we define the endpoint and attach API key from the environment. We also wrap the search query in a clean JSON payload. We send a request, and if everything goes well, the JSON response is parsed into a Python dictionary. If the API rejects the call, we will raise an error. Next part is looking for organic results section. If nothing is found, we return a safe fallback. Otherwise, we take the first result for consistency. And finally, we always return a dictionary with 4 fields: the title, the link, the snippet, and the original query. The agent can rely on this structure every time. Next, we define the fact check tool. This tool takes the result from the first tool and verifies its accuracy using an LLM call. It acts as a cleanup and truth filtering step. We build a minimalistic prompt that asks the model specifically to verify the information and return only the reliable facts. And then we call GPT-4o Mini with a system message enforcing factual accuracy and a user message containing the fact-checked prompt. Finally, we extract the model's verified summary and wrap it inside a dictionary so the agent always receives clean, structured output. So in this file, we define 2 complementary capabilities. One is for finding information and one is for verifying it. Together, they form a reliable, multi-step pipeline that the agent can orchestrate. Next step would be to create the main.py file. In this file, we will handle the LLM calls and the tool orchestrations. First, we start by importing the necessary modules. We also load the environment variables with the load.env and create an OpenAI client. Next, we define the tools list, which tells the models which functions it can call and how to call them. We expose both the web search and fact check as callable tools. Next, we're going to implement the actual logic for the demo. This is a big function, so we will define it step by step. First, we're going to start with the messages. This is a strict system message that forces the model to follow our 2-step pipeline: search first and then verify the output. And then we add the user's question. We will be also adding some print statements along the way. They will help us debug and see what happens under the hood. Next, we enter a loop where the model keeps responding. In each cycle, the LLM decides whether it needs another tool call or can finalize the response. If the model doesn't request any tool calls, that means it already used both and is ready to answer. We print and return the final output. But if the model wants to call a tool, we loop through each call, print the requested tool name and arguments, and prepare to execute it. Then we run the correct Python function based on the tool name returned by the LLM. Using argument unpacking keeps it clean and safe. The next step is to append 2 messages: the assistant's tool request and the tool's actual output. This lets the LLM use the result in the next loop. And finally, we define the main entry point of our application. This lets us run the agent directly from the terminal. You can replace the question with any topic you want the agent to search and verify. Now it's time to see everything in action. Let's open our terminal, type Python main.py and run our application. Now that it has finished executing, let's expand the terminal and see what actually happened. In the first step, the LLM model requested a tool use, which is the web search. With the results of that web search tool, then the LLM decides that it wants to invoke the fact check tool. After the fact check tool gives a response, the LLM is ready to generate the final model response. So that's the full workflow. The agent took my question, realized it needed live data, ran a real web search, then fact-checked the results using a second model and finally produced a clean, verified answer. The key idea is this: tools create capabilities. One tool gathers information, another validates it, and the LLM orchestrates the entire process. This is how you turn a plain language model into a reliable, multi-step system. If you build your agents around these kinds of capability pipelines, you get outputs that are far more accurate, trustworthy, and useful in real applications. With the right tools, your agent transforms from a text generator into a functioning system. Now it can take action, it can access data, it can chain multiple reasoning steps together with structure, it can apply logic that is guaranteed to be correct, and it can also coordinate different models to handle specialized tasks. Tools become capabilities, capabilities become systems, and systems are what make AI do things instead of just describe them. If this helped you understand how modern agents actually work beneath the surface, please leave a like, subscribe for more, and let's keep building smarter AI systems together.